Hi everybody, my name is Gasti Solotki, and I'm going to present to you today our work that was developed at General Motors Israel with my colleagues Oren Longman and Ishail Harat, and with Igal Bilik from Ben Gurion University. Our work title is Clean Receiver for CDMA MIMO Radar. So, what are we going to talk about today? We are going to provide some background about the motivation to use CDMA and the major drawbacks of this MIMO scheme. We will describe the CDMA model we are going to use in this work, present our solution for the elevated side lobes problem, provide some more details about the amplitude estimator block. We're going to show simulated results with the suggested solution, and finally we are going to recap what we discussed today. While you're still concentrated, I want to ask you that if you take one thing from this presentation, it should be the following. A CDMA scheme is a good option for automotive MIMO radars. Elevated side lobes can be handled in the receiver. A major requirement an automotive radar should have is high angular resolution, which is determined by the antenna aperture. The MIMO approach increases the angular resolution for a given antenna aperture, but it requires to distinguish between the different transmitter, target, receiver channels, so orthogonal signals are needed. The code division multiple access, or CDMA, is a conventional method to achieve MIMO orthogonality. It is conventional in communication systems, and it is proposed for radar. In the figure, we can see the major problem with implementing CDMA in radar. Elevated side lobes after the range processing, which mask weak targets, and increase the probability of false alarms. In the CDMA model, we transmit MT different code words from different transmitters simultaneously and receive echoes from L different targets. Each target has its own amplitude, delay, Doppler, and DOA. To the received echo, a white complex normalized noise is added as well. Here we can see the conventional processing chain of a CDMA MIMO radar with a single receiver. First, the input signal is sampled, then it passes through MT different match filters that are matched to each of the transmitted code words to extract the different channels and to estimate the range. Next, the Doppler and DOA information are extracted, and finally the target is detected using a detector. As we mentioned before, the main challenge of CDMA MIMO radar is the elevated side lobes. Here we propose a novel solution that tackles this problem. A recursive receiver based on the well-known CLEAN algorithm. The CLEAN block comes after the beamformer, where the detector is a maxed power detector to detect the strongest target at each step. After the detector, the delay, the Doppler, and the DOA of the strongest targets are estimated, and the amplitude as well. Then we subtract the response of all the transmitted signals that have the estimated targets parameters in the time domain. The process is ended when the maximal power is below a threshold or after some predefined number of iterations. As you might expect, the major drawback of this solution is the increasing computational complexity, since the match filters, the Doppler FFT, and the beamformer are calculated at each iteration. The number of iteration is related to the number of targets in the scene. To improve the computational performance, we propose a more efficient design of the receiver, where the subtraction is done after the beamforming, before the clean block, over a 3D data cube. This implementation is more efficient since the match filter, the Doppler FFT, and the beamformer are calculated only once per frame. But this comes with a memory cost of storing the lookup tables with all the possible responses of the different code words and the target's parameter. Next, we will discuss the amplitude estimator block. The straightforward approach is the least square estimator. The issue with this estimator is that the clean process colors the signal and changes the statistics of the signal model, and therefore changes the optimal estimator, which is no longer the conventional least square estimator. As we can see at the figure at the right, where we can see the noise spectrum before the clean, which is white, and after the clean, which is not white anymore. To handle this phenomena, we develop a novel amplitude maximum likelihood estimator that considers the coloring effect. The estimator incorporates the covariance metric at each step of the clean process. By doing so, maximum likelihood is attained and the coloring phenomena is addressed. Now we're going to show you simulation results of our solution. Here we simulated a CDMA MIMO radar with 4 transmitters and a single receiver, the scenario with 3 targets. On the figure we can see the range response after the conventional process, where we are able to detect only 2 targets and many false detections that originate from the elevated side lobes. The target locations are drawn in purple circles, and the detected targets are marked with green axes. To be able to detect the weak target, we need to decrease the threshold, but it will come at the expense of additional false detections. If we wish to prevent those false detections, we can do that by increasing the threshold, but we won't be able to detect this second target. Next, we will show the clean iterations of our proposed processing. The first iteration, figure A, shows the original signal, where the strongest target is detected and removed, leading to figure B. The second target, which is now the strongest one, is detected as well and then removed, leading to figure C. This figure shows the third target, which was previously masked due to being below the side lobes generated by the CDMA waveform. By implementing the clean iterations, it is revealed and detected, and then we remove it as well. The final figure, figure D, shows the signal without any targets after they were detected and removed, stopping the clean process. We can see that at each iteration, only a single target is detected without any false detections, including the previously masked target. So, what have we talked about today? We propose a novel and modified clean receiver for CDMA MIMO radars. This approach is computationally efficient, and the suggested amplitude estimator considers the signal noise coloring effect. Finally, we salute you all and hope to see you next time at Dublin. Thank you very much. Goodbye.